know, for example, in university where I'm at now in Cornell, they have this IC3 project where it's like a collaboration with industry and the university research, where like they do this web seminar from time to time, where they just the business people want to know what is the latest update in the research community, so we just update them. So I guess this kind of conferences, one objective is something similar, just everybody to come and see what is the latest things that people in the academic community are talking about. I like the idea that like the money is not controlled by human that can make arbitrary decisions, but it's controlled by like an algorithm that is known to everybody. It's predefined, and this is the way that it works. And I think it has a nice potential. So this is the basic idea. There are probably many answers to this question. So basically, if you want to settle data, is to reach an agreement between different businesses that maybe are distrustful of each other, but you have this public blockchain where you know that what you put on the public blockchain become irreversible, and this really happened. So now they can use this blockchain for their agreements in whichever ways that they want. This is just a very high-level generic point here, but probably there are more specific use cases for blockchain. So now again, it's a question whether you use like a simple blockchain that is more scalable, like Bitcoin, where everything is very simple, or use something more complex with smart contracts. And now the question is, what are the interesting use cases for the smart contracts that maybe businesses can use? There are actually many. So the toughest research question that I'm working on right now are related to this trying to achieve better cryptocurrency protocol that is not using the chain, but using the more complex topology. So this is what we call a mesh. And so this is actually similar to this. There are several projects that are in the real world, but they are not very good. The famous one is called IOTA, but we want to do this a secure, provable way of cryptocurrency that is not using a chain. It has very nice features, and the latest thing that I'm working on is combining this idea of the mesh with another interesting component, which is replacing the proof of work as it is done in Bitcoin with what we call proof of space or proof of storage, where this kind of a protocol, the security is done by committing to some data that you say, I'm really keeping this data, and this data will make me eligible later to create a block and get reward. So this kind of protocol is much more energy efficient. You don't need to do all the computation and waste the energy all the time. And if this can be done in a secure way, it gives a different way to do something compared to Bitcoin, and there are very interesting trade-offs. So to prove the security of such a protocol, this is very challenging. I guess there are two questions, so there can be two interesting questions. One is whether the tokenized Bitcoins are ready to use. The other is whether, let's say, the actual use case for them, like this trust-free poker, is ready to use. The answer to both of these questions is no right now. So I'm involved with both of these projects. So the one about poker, this is on Ethereum. This is an ICO that is going to happen, I think, somewhere in the beginning of next month. I'm not sure exactly about this decentralized poker, and there are several implementations of the poker with different trust levels. So there is one level that is already implemented and can be used, but the one that is completely trust-free is not fully implemented yet. And actually there is also an intermediate level of trust using the trusted hardware that gives really good efficiency that for the poker also, and this is also not fully implemented yet, but we are working on it. This is one. The other is about the tokenized bitcoins. So this is also not implemented yet. We have just a very basic demo of this kind of a decentralized exchange with the trusted hardware, but we are trying to work into a deployable version that actually works in the real world. If the exchange service itself is working, let's say I just want to trade the bitcoins for Litecoins and Ether and ERC20 tokens and Ethereum, if this kind of thing is working, then adding the extra support for tokenized bitcoins is actually quite easy. Yeah, so this is actually a very good question. So just if we don't talk about the token, if we say just the user who want to trade Bitcoin for Ether for Litecoin, so the security property that we get is that we get really good security in the sense that either the trades that they wanted to happen will really happen and the new balances will settle on the blockchain after a period of time, a fixed period of time, or if there is some attack, all the user will just get the original money back. So this is what we get just when you want to trade the cryptocurrencies that already exist. With the tokenized Bitcoin that are kept in a reserve inside the secure enclave of the server, the security that we get is that we are doing this replication scheme where the data of this reserve output is replicated among many servers that have the secure enclave, and the secrets cannot be known by any human. They are known only to the secure enclaves. And the security property that we get is that if at least one of those replicated servers is still alive, then the tokenized bitcoins are okay. They can be redeemed in exchange for the reserve output that at least one of those servers still have access to. If all of the servers are destroyed, then you lose the reserve output. Yes, so the way that I describe everything, I just assume that this Intel SGX technology for trusted hardware is like ideal. It's not actually ideal. There are some problems, and also they are working on the next version of it that will also have better features. And there are in the academic community, there are many kinds of attacks on SGX. So some of those attacks are very interesting, but not directly relevant. For example, they run some algorithm inside the secure enclave that is processing some image, and this is interacting with the main memory of the computer, and you can do this side channels attack, and even though you cannot retrieve the entire original image that is supposed to be secret, you can retrieve enough data by side channel information and know what the image is more or less looks like. In our case, with just what the enclave is storing is just cryptographic keys and don't really need to interact with the main memory, it's much more resistant to this kind of side channel attacks, because the data is only inside the enclave itself, not in the main memory. It's much more difficult to, and this is also using this constant time, constant memory algorithms that are very difficult to do side channel attacks against. So it's and as I said in the presentation, this is already strictly more secure than the centralized exchanges where the money is controlled by humans who has all the secret keys. So in this case, it's probably true that there is no human who can gain access to this secret data. Yeah, so when you add this extra layer of privacy, then you add a layer of complexity to the protocol. So some of the Bitcoin developers actually, and some anonymous person who came up with this Mimble-Wimble protocol, so that one is actually has some even better efficiency than Bitcoin, because you don't need to keep the history from Genesis. You just from the latest state, you can be convinced that you have the real data of the ledger, the blockchain. So, but this is like a very radical change from Bitcoin. So to have a protocol that is Mimble-Wimble instead of Bitcoin, like to replace Bitcoin with Mimble-Wimble, this will be very controversial. So there are these others like Monero, Zcash that are just doing a separate blockchain than Bitcoin, and then they can try to do it from scratch, to do the version that will give better privacy. your question was about just as Bitcoin as it is, but try to add privacy to Bitcoin in a better way. So what are the good ways to do that? Yeah, the interesting question, I think, is that you can add the confidential transactions, not like in Mimblewimble, but add confidential transactions such that you can still use scripts. So you can still have the scripting language of Bitcoin. So this will be significantly less efficient than something like Mimblewimble, but it still gives you the advantage that you have scripts. So it might be nice to add confidential transaction to Bitcoin, still have scripts, and say this is now give you better privacy, and this also so the thing that can be used already now in Bitcoin to get better privacy is these mixers, and the mixers work much better if you have confidential transaction where you hide the amount of coins that are being traded. So if Bitcoin will add confidential transaction, now the mixers will also work better, and you can get even better privacy guarantees. Yeah, so yes, and the mixers there are different kinds of mixers. For example, I have one project about mixer, again using this trusted hardware. You can do the mixer with many inputs and outputs, and this gives you the greater the anonymity set that is being used for the mixing, the better privacy that you get, because you don't know who is who among a larger set. So there are different kinds of ways to do mixing, and they can be quite practical, and with confidential transaction it will be even better. Well, better or not, it's like unavoidable. You cannot stop people from doing what they are doing. I would say that a lot of the other projects don't make any sense. There are a huge number of projects on the list that are completely crazy. Some of them are nice, at least to explore, to see whether they work well. Yeah, if you ask whether there are too many, I guess in the objective sense, yes, a lot of them, it's too many and they don't make any sense, but you can stop them. So we'll just let the market decide eventually.